Okay, we're going to talk in this screencast about the chain rule of differentiation, and see how that benefits us and helps us differentiate functions. Now remember, when we differentiate, we're finding the gradient function. I'm going to keep emphasizing this point, it's going to drive you crazy. But when we go from y to dy dx, this is the rate of change of y with respect to x. That process is differentiation, and it also is that guy there. Let's call him the gradient function, because what he does for us is he finds us the gradient. So that's what he does, right? So what we want to do is we want to be able to be really good at differentiating, at finding gradient functions, because we know how useful it is to know what the gradient of a function is, or the gradient of a curve at any point along that function, or along that curve. Okay, so we're going to spend a lot of time just honing our skills. So far, we know this, don't we? We know that if I've got a function such as this, then my gradient function, because we're off our L plates, we've got our license, the 2 comes down to x, 2x just goes to 2. If you like to look at it this way, that's 2x to the 1. The 1 comes down times 2 is 2, 2x to the 0. All right, next to the 0 is just 1, so that's just 2. Okay, so this is what we've got so far. Now we're going to just get a little bit funkier with things. We're going to start to bring in some different types of equations. So the chain rule is going to help us do things with functions such as 3x minus 2 to the power of 4. All right, so I've got that, and I want to find dy dx. All right, now here's the chain rule. Now we're going to get dy dx, sure, but we're not going to go through. I'm not going to expand that out because that's just going to take too long. What I'm going to do is I'm going to make a nice little substitution here. I'm going to let u equal to 3x minus 2. All right, but this is all part of a grand plan, and the grand plan is this. I am going to utilize the chain rule, which is simply, I can get dy dx by finding dy du and multiplying that by du dx. Okay, if I can find the rate of change with respect to x, of y with respect to x, I can run through u here. If I know what dy du is, the rate of change of y with respect to u, and I know what the rate of change of u with respect to x is, then the product of those two will give me dy dx. It will give me that. So this is a little thing called the chain rule. Right? This is the chain rule. You can see why it's called the chain rule, perhaps because it's a chain. It's a multiplication chain that gives us what we want. So when we refer to the chain rule, we're referring to this guy here. All right, well, let's get back to work here, because what we want dy dx. That's the goal. But we're going to get it through a chain. All right, I'm going to bring in u, because u equals 3x minus 2 means that now I'm not. This is a horrible looking function. This is huge. This is 5 terms. It will take me ages to expand it out. But I tell you what, if I've got y equal to u to the power of 4, that's nothing. All right, dy du out of that is easy. 4u cubed. Easy peasy. Alright, but that's great. So dy du comes out of that, but where does du dx come from? Well, we've got out of this here, u equals 3x minus 2, I can say that du dx is equal to 3. Alright, so now look at this. What we've got is, therefore, dy dx is equal to, using the chain rule, dy du, there's dy du there, 4u cubed, times, there's du dx there, times 3, so dy dx is actually equal to 12u cubed. One problem with that, though, it's in terms of u. I don't want it in terms of u, I want it in terms of x. So now I go back, the last step is to bring my x back in for u. Now u equals 3x minus 2, so I write 12 3x minus 2 cubed, and there is my derivative, dy dx equals, right, on big box around that because I'm proud of my work, 12 3x minus 2 cubed. Right, there it is. So that's all good. Let's do another example. Do we need to do another example? How long are we into this? 4 minutes 58. I wonder if, yeah, we'll do one more example. All right, so differentiate y equals 1 minus 3x to the power of 7. Okay, all right, forget that. We're not expanding that out. I've got no time for that. So I'm going to replace my 1 minus 3x with u, and that means that my du dx is equal to minus 3. All right, that's good. Right, I'm going to rewrite my equation now as y equals u to the power of 7. So my dy du is 7u to the power of 6. All right, getting the hang of this? So therefore, my dy dx is dy du, 7u to the power of 6, times my du dx, which is minus 3. So I get minus 21u to the 6, which is minus 21. Use 1 minus 3x. 1 minus 3x to the power of 6. And there I've got my derivative. Now, all right, hold on a sec. So, all right, let's have a little look at this. I started with this. Can we just line up our results here? So my two results here are 3x minus 2 to the 4. So if I just line these up, if I line up my fx alongside my f dash x, all right, and I'll just make a little column table here. So I had, what did I say I had? 3x, what was the first one? 3x minus 2 to the power of 4. 3x minus 2 to the power of 4. All right, and then the next one was 1 minus 3x to the power of 7. 1 minus 3x to the power of 7. All right, now what did that derive to? Well, it derived to 12 3x minus 2 cubed. And this one went to minus 21. It's just here. 1 minus 3x to the 6. So let's have a look here and see if we can see a pattern, because that's what we look for, isn't it, in math? Patterns, shortcuts, get off our L plates. How do we do this? Well, all right, look at this. The 3x minus 2 stays, doesn't it? 1 minus 3x minus 3x. So the bracketed term doesn't move. What happens to the power? It drops by 1. 4 to 3, 7 to 6. So far, so good. What happens out the front here? This number here is 12. All right, what we're used to doing is taking the 4 down and sticking it down the front. So 4 down there. Think of 4. How did it become 12? Well, have a look inside here. What's the derivative of what's inside? You know, what we replaced for u, 3, isn't it? So remember, we always just we find du dx from that. So the derivative of what's inside the brackets times the original index is the number out front. Just have a look, see if that works here. So 7 times minus 3 gives us minus 21. So can you say, if I give you, let's go with 4x plus 1 to the power of 5, what's that going to go to? So, right, see if you can do that. Pause the video now. Pause the video and see if you can get it, and then come back and we'll see if we get the same thing. Okay, you took the 4. I know you took the 4x plus 1 down here, because you can see that doesn't change. I know you reduced the power by 1, because that's great. What goes out the front there? Well, the original power times the derivative of 4x plus 1, which is 4. So 5 times 4. Did you put a 20 down there? If so, congratulations to you. All right, so that is our chain rule pattern. If you're in the mood for it, then if we've got y equals a function of x, some function of x to the power of n, then do y dx will equal n down the front times the derivative of the function inside the brackets there. All right, that stays now to the power of n minus 1. All right, that's a nice little rule as well, isn't it? It's the chain rule. Okay, let's do one more example. See if you can do this like you did a minute ago without my help. So I'm asking you now to differentiate. I don't know, once you've written this down, just pause the video. Differentiate f of x equals square root of 3x squared minus 4. Right, pause and have a go. Okay, now here I go. I'm going to use the chain rule. I'm going to rewrite this as 3x squared minus 4 to the power of a half. Hopefully you did that. All right, that's our first task, is always to get square roots in terms of fractional powers. Now, what happens here? The half's going to come down and be multiplied by the derivative of 3x squared minus 4, which is 6x. So a half times 6x, all right, that's the n, see the n is the half, times the f dash x, the derivative of this function, which is 6x. All right, now what happens to the 3x squared minus 4? Nothing is what happens, that stays. The half, what happens to the half? It drops by 1, doesn't it? Right, minus a half. There we go, I've just got to tidy this up now. Half by 6x is 3x by 3x squared minus 4 to the minus a half. And just to tidy this up, because I don't like negative fractional powers, it's negative, so it's underneath in the fraction. It's a half, so it's square root of 3x squared minus 4. Excellent. Thank you for your attention. Exercise 4I on page 193. Let's go and do that. I'll see you soon.